This is lesson 5.3, Simplifying Expressions. Let's review a couple of topics that we've already had. In lesson 5.2, the last lesson you learned how to distribute, which meant whenever you saw parentheses in an expression, you multiplied the term directly on the outside to each term on the inside. In lesson 5.1, you learned how to combine like terms, which meant that you identified your variable terms and then added them together using the rules of integers, SOB, and then you combined your constants together, again using the rules of integers. Simplifying expressions uses those two concepts, distribute and combine like terms. In fact, you will do them in that order, those two steps. Whenever you see the word simplify, it means to distribute and then combine your like terms. The difference between simplifying expressions and evaluating expressions is that when you evaluate expressions, you will always get one numeric answer. For example, when you had a numeric expression, an expression that contained nothing but numbers, you had to use those rules of you had to use the order of operations, and then you got a single number as your answer. Another time you had to evaluate an expression is when you were given an algebraic expression, but they tell you what the variable is equal to. You had to substitute that variable in or replace that variable with the number that you were given, and then once again use the order of operations. So when you're evaluating expressions, whether it's numeric or algebraic, you will always use the order of operations, and you will always get one numeric answer. When you simplify an expression, that's when you may still have variables in your answers, and you also may have more than one term. It is possible when you simplify an expression, though, you could get just one term or even just one numeric answer. And just recall that the word expression means that there are no equal signs in the problem. This is a good indication that you either need to simplify or evaluate. In our next lessons, we are going to learn how to solve equations. Equations are different from expressions. Equations are made of expressions, but they have to have that equal sign. All right? You cannot solve expressions. If there's not an equal sign, you cannot solve them. All you can do with them is either simplify them or evaluate them, depending on what you are given. Alright, so let's practice simplifying expressions. Okay, you're looking at problem number 1 on the 5.3 practice page. So to simplify the expression, remember we do two things. We have to distribute and combine like terms. Oops, a little fast there. Distribute and then combine like terms. When you distribute only the term that's directly beside parentheses. This term may be to the left or to the right of the parentheses, but all these practice problems, I believe they're all to the left. So when we say just the term directly beside it, that's this -7 here, not the -2. The -2 is a term by itself, but it's not sitting side by side to the parentheses. We're not going to do anything with that -2 right now. You will distribute the -7 by multiplying it to each term on the inside of the parentheses. So you just copied down the -2 that started the problem off because we're not doing anything with it. -7 times n is -7n. -7 times -2. Don't forget those signs. The signs go with the numbers. I can't tell you how many people put down -14 and forget the signs. Is +14. You do need to write the plus sign in between because it's not the first term in the expression now. Only when it's the first term will you ever put not put the sign in. Alright, now we're ready to combine like terms. Locate your variable term first. Don't forget the signs that come in front of the terms. So our first term is negative 7n. There's no other variable terms in the expression, so we simply copy it down because there's nothing to combine it with. Then identify your constants. We have a negative 2 and a positive 14. Combine them. Remember, you use the rule of SOB. If they're the same signs, you add, opposite signs subtract. What do we have here? A negative 2 and a positive 14. Are those same signs or opposite signs? They're opposite, so we have to subtract. Don't forget that the bigger sign wins, though. So what we mean by that, 14 is bigger than 2, so we should get a positive, and yes, you have to write that sign down, even if it's positive. Positive, say 14 minus 2 is 12. And that's our final answer. We have no parentheses in our answer, and we do not have any like terms. Let's try another example. Alright, what's our first step? Distribute. And what would you need to distribute in the problem? The negative 7. Okay, so negative 7 times 4x, and negative 7 times what? Negative 7. Don't forget that sign. Alright, so let's write down our answer. Negative 3, we just copy down, minus, because a negative times a positive equals a negative, 7 times 4 is 28, x, don't forget your variable, and then negative 7 times negative 7 is a positive 49. Our next step is to combine like terms, so look for your variable terms. We have a negative 28x, so you write down that first. There's no other terms to combine it with. Then locate your constants and combine them. Those are opposite signs, so you have to subtract. The bigger sign is positive, so I have positive 46. And that's your final answer, negative 28x plus 46. You can do number 3 on your own and check it later, but I want to skip over to problem number 4 and give you an example of what you do here. Again, to simplify our expression, the first step you need to do is to distribute. So what term here is directly beside our parentheses that we would need to distribute? It's this 4 here. If you see a plus or a minus sign that separates the term, for example, this negative 5x, because that's a minus that's right beside it, you would not distribute that negative 5 in. Alright, so let's multiply the 4 times the m, and then the 4 times the positive 1. 4m plus 4. Copy down the negative 5m. So we've distributed, now you're ready to combine like terms. Identify your variable terms. You have a 4m and negative 5m. What's the sign of that 4m? If you don't see it, remember that it is positive. So use your rules of integers. If they're same signs we add, opposite signs subtract. These are opposite signs, but the bigger sign wins. 5 is bigger than 4, so your answer would be negative m. You could have put negative 1m, but remember in algebra we don't usually like to write the coefficient of 1. But if it is negative, you still must have that negative sign there. One thing you might want to do also is after you've combined your like terms is to cross them off. It helps simplify and keep your eyes so that you can see exactly what you have left to combine. We only have one constant, the positive 4, so there's nothing to combine with. Just copy it down. And there's your final answer, negative m plus 4. Alright, let's see if you can do it. Look at problem number 5. What would you do first? Multiply 7 times x to get 7x. Multiply 7 times positive 5 to get positive 35. Did you do the same thing so far? By the way, push pause if you need some time to work on it. Then did you carry down your 5x? because the term is outside of the parentheses. After you've distributed, you're ready to combine your like terms. You combine your positive 7x to your positive 5x. You get 12x. And then just copy down the only constant in the expression. So your final answer should be 12x plus 35. If you want to do problems 1 through 20 and then check yourself to make sure that you're getting the hang of this before you continue watching this, I'm going to start looking at some a little bit more spicier problems, starting with problem 21. So you can either choose to do those first 20 problems for practice, or you can continue watching and look how this even applies to a little bit more complex problems. So when you're simplifying an expression, remember you have to use the distributive property if you see parentheses. In this example, you see 2 sets of parentheses. Okay, you just need to distribute twice. It's okay, it's no different. You multiply the term on the outside of the parentheses to each term on the inside. So we get 8n plus 40. And then we have this term that's outside the parentheses, the second set of parentheses, which you need to multiply into the second set of parentheses. Don't forget the sign though. That's a negative 10 times 4 equals negative 40. And a negative 10 times negative 5n, which equals a positive 50n. Now you're ready to combine your like terms. Identify your variable terms first. Use those rules of SOV. That's a positive 8n. So 8 plus 50 is 58n. And then combine your constants. Now what do you notice about these two constants? You have a positive 40 and a negative 40. What do we call that when we have two numbers that are exactly the same except for their signs? It's called a zero pair because they equal 0 or they'll cancel out. You could put plus 0 here, but you don't have to. And in fact, if you're taking the ECA, there will be the multiple choice answers will only have the 58n. So in this example here, our final answer is only one term, 58n, and that's fine. There's still a variable in the answer, which is fine as well, because we know when we simplify, we may still have variables in our answers. Now the one thing I must warn you about when you're combining your like terms is we had a zero pair here because there was a positive 40 and a negative 40. Please don't follow in the habit or make the common mistake of simply crossing them out just because they're the same number. For example, if you had a positive 40 and a positive 40, that is not a zero pair. Okay, that would equal 80. You would have to add them together. Alright, so just be cautious of that. Let's do another example of this type.